Hello, people. I have no idea what she just said, but I'll assume it's great. Thank you. Thank you for a warm welcome. I've come to talk to you about schema, about development of applications on the web so that they can talk with each other well and to have good interfaces between them. How many of you do something on web? Could you raise your hands? The vast majority, as expected. So this will be an interesting talk for you. So I'm going to go through this presentation. I'm going to have some examples. We'll have some live, I'm not going to call it coding, live. You'll see soon enough. They're great. Do a small application. One person can do it. Do that with 20 people. Everybody's making small application. Everybody is very effective. And then comes time to integrate those, and it breaks. That happens. We try to avoid that. And we'll get to that in a moment. Examples are going to be a little bit ridiculous. You'll see. But all the principles are actual real code that we use on production. So who am I? Who are we? My name is, I'm a dev, the dev. I work in Kiwi as a lead. And I lead a team of half a dozen people. So we work on services that we sell to our customers who fly with our offering. We're an tries to sell travel. And we sell it in a simple way, A to B. Multiple airlines, single airline, bus, train, we don't care. We provide baggage that you don't have to think 3 times before buying. If you buy it, you get the dimensions, it works. Doesn't always, but when we don't have an outage, it works. We use Python and some other applications. You can ask me later if you're interested. And we're very technologically oriented. We go for with technology, not with manual work. And we try to have all these APIs that other airlines provide put to good use. So basically, we're a tech company that specializes in travel. So yeah, we develop these services developed by different people. Many of these people like to communicate about what they're doing. And you need managers, usually. You have people talk to other departments, to other team members, things like that. And many of you have talked about API responses. Okay, I'm going to use your service. What do I need to send? What will I get back? Raise your hand if this is familiar, please. Exactly. So yeah. These things can sometimes cause misunderstandings. You've probably had delays because of it. Sometimes the colleague you were working with gave you something wrong, and now you have to wait till he's back from vacation. Or she made a typo, and your whole project is on stop until somebody fixes the typo. Or a schema application does. These are common, and they're very common. They break applications on a daily basis, and typos have caused. We want to do this via code. We want to programmatically combine all these services and make them work. Make it work. If we manage this, we have a lot of improvement in consistency, maintenance, and communication, because then everything will work without having to go through people, through manual interactions. And that's great. So yeah, I'm going to show you how to do this using schema, in this case, OpenAPI schema. We're going to chat a little bit about going API first, about not writing a line of code until you know what you'll be writing about. We're going to see what kind of tooling is there, what to do. We're going to talk about connection, which is Python specific. We're going to talk about Flask. We'll see how we share schema. So multiple teams can do the same thing And we're going to do this with an example, with a conclusion that shows how this all should work together. The example, Python, Connexion, Flask, Swagger, OpenAPI, you'll see. Birds are going to be a motive, to be one for keeping and registering birds, the other for a database of birds. You'll see. It's a made-up example, but it's a real use case. Replace birds with products, and you have a company specializing in transporting goods, so on. So yeah, you know what API is. Be internet in this case. Most people take this as a release your API on the internet. It's your product. It's something that's not really changeable, at least not easily. And all the changes will start costing. When you're a small startup, doesn't matter. When you grow big, the mistakes from the past come and hit you. Schema comes from Greek. It's, to keep it short, it's a plan, an idea, it's a design. We're going to focus on doing these designs first because professionals do it that way. You won't let a doctor figure it out when he opens you up and starts cutting. You want him to know what we are doing. We want to know what we're doing. So yeah, that's it. We're going to plan. We're going to make up some idea of what we want to do. We're going to get approval from peers, and that's going to help us separate from the how. And with programmers, with us, this is usually the problem. We usually start with the how. We start coding stuff, and then we kind of adapt the product to fit when you're doing something for yourself. But involve 100 people, and this breaks. And that's the thing. We want to... Oh. Okay, a moment. They started...
Expected to the word breaks. I think that's the problem.
They started licensing our product from... And my Wi-Fi broke. There. Apologies. So yeah, we're going to write down what we want to do before we do it. And this is great. This is going to help us. It's going to prevent many people from being reckless, as in starting to code before they know what they're coding, and then having to go back, which is great. And it doesn't mean it's not agile, however much of a buzzword agile is. So yeah, schema, OpenAPI. Any of you used OpenAPI? Well, quite a bit, people. Good. The latest one or Swagger? Swagger mostly. So yeah, this is in OpenAPI. There's a version in Swagger that I presented already. I updated it, and that's also a point. I managed to update this presentation in half an hour using the tooling they have. That's great. Whoever changes a huge version in half an hour, try it with Python. So yeah, there are some steps. Go through them a bit. Parameters, paths, definition. It doesn't matter that much. It boils down to code quite easy. It's easy to learn, but it's a standard way of describing things, and that's what we need, and that's what we'll use. So yeah, I'm going to show what our schema is. Okay, so we've got this application that I mentioned. This is Swagger, to keep it simple. We said we're going to talk about birds. Our birds will have several simple properties. They'll be named, and we'll need to have a standard name for those birds. We'll define it as a bird name. They're going to have a nest. We're going to define it as a nest, as a class. And we're going to add wingspan, because why not? It's a number. So yeah, let's say the name, 1 to 128 characters. Why not? It's unique to the bird. That's our constraint. And it's defined here. It's a string. All these are going to be defined while you're planning the project, not after the code is written. And these constraints are a good starting spot for everybody to start implementing. Usually, when you start coding, you wouldn't think about length of your strings. But then somebody else will misunderstand it and start sending you huge glyphs that break your application. Determine it ahead. And then we'll have a nest. We're going to say that it has some terrain, where those nests usually are found, and some type. Nests have types, if you didn't know. Basically, it'll be a simple set of enums. These are all simple, relatively trivial objects, but they are building blocks. And then we'll build two applications. One of them will be the keeping one, bird keepers. We put in some metadata, so everybody knows what our application is. And we define some paths. Most of you know what paths are. I don't think anybody here doesn't understand a web path. Could you raise your hand if there's somebody? Ah, great. So yeah, paths on the internet. We're going to describe them, the methods, HTTP methods. Operation ID is how we're going to connect it to our application. That's a function that will be called. And then we have some more metadata. A response, successful bird, fair enough, returns an owned bird. That's pretty much a bird that we've mentioned already. We defined it. And it has an owner name. That's a string. So some simple typing here. Nothing too extreme. And maybe so you can see it, is that this schema of the application is independent from the definition of what a bird is. So our bird keepers, the application does not know, well, does not define the bird itself. It's defined before. We all sit at a round table and we say, okay, what's a bird? We define the set of attributes, and then they go use our attributes to code their application. So you have multiple services, multiple teams, and they all use the same building blocks. Makes it super simple to collaborate. So yeah, solution for us. Why OpenAPI? Why did I just show you this? You might have thought, okay, this can be done in JSON schema. And you would be right. It can be done in JSON schema. It can be done in other scheming languages. OpenAPI has a lot of tooling behind it. That's great. That's amazing. It has the biggest community yet, and it's all over. You can find it in many different places. And the important part, and especially for this presentation, it has connection. Connection is a great tool. We'll cross it. It allows you to use application, figure out your application. So, a small digression, we chose YAML to make it more human readable, to make it obvious who should design schema, not just programmers, not just somebody who quotation marks and colons, but everybody. Everybody should be there, and everybody should collaborate. So more human readable, the more obvious our message is, the more obvious it is to get people to work together. Bonus, I get half of the schema, which is always great. So yeah, connection. It's a framework on top of Flask. It's great because it's light. It uses introspection into your schema to validate responses because it's great. If you break your own application, it's going to break on you, not on me, who I'm your user. If you don't follow your own schema, you don't get to release, which is amazing. We block you from releasing, so you have to fix your own problems. It all stays in your own bubble, and all the problems you can fix on your own. That cannot be overstated. There's no need to integrate until you know that your solution works as you've described it. Flask, it's fast, it's framework. Say you have a lot of opinions, you can do whatever you want with it. And that's why we chose it as our baseline, because we do a lot of different things at Kiwi. And having a mega framework would just slow us down. This way, many small things. It helps us a lot. Yeah, that's the combination. There's not a lot of bloat. We do only what we need. In the example, I've used the same tech stack. I skipped any databases. I just used some in-memory dictionaries. This allows you to do many custom things, and we do. So yeah, schema, as I mentioned, needs to be enforced. Connexion forces you to follow your own schema, and if you share it, it forces all the teams to speak the same language over the web. So, if this was done, maybe you use SOAP, which is kind of volatile. Your documentation grows old. Somebody tries to implement your service, and they cannot. They end up not doing business with you. Use hundreds and thousands because somebody didn't update your documentation. This is ridiculous. We want our documentation to stay up to date. We want our code to document itself. And this is, to an essence, that. You get Connexion to have this schema, and instead of code, you just write Connexion schema. share this here modules that they don't share code. They only import the schema and share that, which is an important point because you don't reuse, you reuse your code, but you don't mingle your logic. I approve for my team, my colleague Jakub approves for his team. And they develop, we develop our parts of the system completely independently. However, we both follow the same contract. And see, here we can see the examples are all the same. The schema is all the same. We can change this, and relatively easily. Oh, I can show this. So we want to create a new bird. So we want to add a new type of terrain. Here we can see in schema that the bird has a certain set of viable terrains of nests. Swamp, plain, forest, and universal. And let's say we want to do an operation that's not destructive. We want to add another. We do it in one place and add, I don't know, what do I have? Beach, or yeah, beach. And we rerun our applications. So, release. We'll restart it, and we'll check the schema to see that it has been updated in both of the applications, allowing the beach. The same will happen here. And we've done one single centralized change. And this change is a part of something that's automatically validated. So, if you make a destructive change, if you remove one of the types, your whole test suite would fail. Your application would not allow you to return values like that. For example, moment. That's a register. We have a list of some birds that's, let's say, our database. One of them has a swamp as an active bird. Let's say somebody decided to wake up one morning and say that swamp is not correct. It should be wetlands. They decided, they save it, we restart, we go to, this is bird keepers, we need bird watchers. We run our restart our application. Okay, everything works so far. Wrong one. Everything works so far. But we try out to get all the birds. And we get an internal server error of 500. What does that mean? It means, and our alerts will tell you, that we messed up, that we made some mistake. Our server will stop executing things and tell us, hey, fix me. And this is great. In this case, I'm doing it personally. In most companies, in almost everywhere, you will have a test that will not let you release before this is green. A rudimentary test. So it will not allow you to release things like this and break your colleague, because your colleague calls it swamp. So your colleague has a certain implementation that he relies on, and you cannot counter it. You cannot change it without agreeing him. So yeah, oh, this is all cool. We have, how can we improve? In this example, I didn't go that far, but you can do a multi-team access. So instead of just back-end teams communicating, you can have a front-end team pull on this schema and automatically generate their code, their components. Many front-end teams are crazy about GraphQL. That's the same amount of flexibility, even more, without having to do too much that you are not already doing. It allows you separate, as I mentioned, version your schema, keep it better and more secure against changes. It allows you to lint, which is also great. Many companies just have people figure it out as they go. There's no process in making schema. If you add linting, at least you have a step in a right direction. You follow some international standards, you follow some conventions that the community has decided. And that's great. You share your best practices, and it ends up obvious mistakes that you regret when you know more. It helps everybody grow. So this product, as we've seen, will use the same schema elements to have multiple services. So you can have all these different things to share the same language, the same idea. These important changes can be audited more carefully, and the terminology should match the real code. Because if you have this library of terms, of expressions, then why wouldn't your product people use it? Why wouldn't your salesmen? Why wouldn't your colleagues who are not programmers? It's readable, it's YAML, it's not cryptic. Everybody can go on and read it. They don't need to understand code. They just need technology. So, as we did this, we can, okay, let me undo the changes. As I mentioned, there are completely different applications that I have to stop and rerun them individually. So, what's the idea? We'll get the list of all birds from one application that serves as a repository, as a place where these birds are all registered and work. We can always take one of those objects that we know is correct, and let's say, imagine a front end doing this. Literally, picking one item out of a list. And then it can comfortably go to another API, to a different application, and register that same thing here. So instead of having to build this, they know with full confidence that they can reuse the same object, registering a common pigeon instead of whatever that was in the example. And let's say some owner is there. And this way, they are confident that they don't need to double check, that their applications, their interactions will allow and have a successful, oh, not actually. What happened? Okay, there was a bug. Owned bird. I managed to name something wrong. Give me a moment. Okay, owned bird, and here it's called bird. I think this is it. This needs a refresh. Okay, it seems that the porting it wasn't completely without mistakes. Issue. Register missing one positional argument bird. The schema, that's bird keepers, bird, owner name. Dictionary.
May I do a suggestion? Probably in your request you create new owner without any bird class entry, only specifying owner name. And probably if you will use some existing owner, you will not get this problem.
Okay, let's not dig into it now. But yes, the validation, and I'll have to fix this on the GitHub. This code is public, so you can share it, and you can get it. I will share it, and there it works. I have updated it recently, so it was a small bug, but doesn't matter. But yeah, if you define these two ahead, you make them a core part of your product. And it's an important part of your product. These things work best if they are planned first. And with a couple people, it's okay. But with a bigger team, it really does need to be discussed so everybody is on the same page. Reusing the terminology, reusing the same thing is great. You then have all this shared and not just the code. It's a product. If you do that, this tight interface pays for itself, and many times over. You will have people not ask you the same question every month, and you have different teams have many less conflicts. At Kiwi, we did this for our flights. We defined a single thing, a flight, that has this list of attributes, and we reduced the amount of bugs there tenths of times. From having breakages, because somebody would expect a key in a flight almost every week, we got to nearly never having a problem with them. Because we could all know what to expect. What object will have and how it will work. And it reduced integration times by weeks. Generally, there were not too many layers of going there and back and trying it out and it doesn't work and stuff like that. Our testers got a huge break. So yeah, how to start this? How to start doing this on your own application if you aren't already. Use a schema. OpenAPI is the best. Swagger is a close second. It's slowly expiring. Process is there. Establish a process. Separate it, version it if you can. The schema is best away from code because you want to break your code into more pieces and then you will not be sure whether to duplicate where completely different repo. Phil Sturgeon made a great article how you can get a specification, a schema from nothing pretty much, where he explored different methods to look into what you have now and get the schema and specification out of it. It's a great article. Check it out. And you have this repo online on GitHub. The slides can be found on my website as well as a video. This is like the slides to take a photo of if you want notes. But yeah. So yeah, schema is pretty useful. It's a great thing to do, especially when you have to cooperate with multiple teams. It makes it a much easier job to design and to integrate. You get to talk less and document things more at the same time. It made us all efficient, and the more of us developers are using it, the easier it will be to work with everybody else. The more applications I integrate that have this defined, the happier man I will be. And you as well, men and women, will be much happier if you have something defined and you don't have to do archaeology in code to figure out how something works. You have a nice interface and it all works. So use schema, please. Thank you for your attention. Let's do questions.
Thank you, team. Team Markovic, yeah, I'll see the first question.
For the speech. The question is it possible to specify whether your API endpoint requires kind of authentication using custom HTTP headers with this?
Yes, you can plug in whatever you want as an authentication flag, and then it calls either some of the pre-made, like the bearer token and so on, or simple out, and that's built in, or you can define your own and overwrite it. That's why we love Flask. It allows us to do exactly this with some old deprecated, currently in deprecation security methods.
Thank you. And another one question. What is the best approach would be to create backward incompatible changes? Like you probably deprecate some endpoint or maybe parameters to your endpoint, and you roll out the new version of API, but you want old client that not updated to the new version. They should work with your server.
How to deprecate it?
How to properly do this?
Use the sunset header. There's a header in HTTP spec that says, okay, this endpoint is going to be shut down at this time. OpenAPI also supports it, so it kind of grays out everything. And get your clients to do it. There's no real other way. We do this, and we also make reporting over the endpoint to see it lower down. So we just monitor it closely and push people. Come on, do it, do it. But it's a big problem. Once you release something to the public, deprecation is multiple months, even years away. So you cannot change your mind easily.
Good.
That's why this is a great approach.
Thank you for your presentation. I have a question according to your example and common schema. In your example, you have two repositories which have a common root. But what if we have separate repositories in a, for example, one on GitHub, for example, another one on Bitbucket? And how can we provide common schema? Can we provide remote schema for it? Thanks.
Yes. OpenAPI allows you to load your schema even live, dynamically from the web. We don't use that. We do package it as a Python package, and then you just use it as any other package. You access its files and work with it. So we package it as a part of Python, as a module. So that doesn't matter which repo it is. We don't do it on the repo level. We do it on the package level.
Thanks.
No problem.
So, as I saw, when you upgrade something in your schema, you also need to test that it didn't break anything in services that use the schema. So, doesn't it make your CI too long?
Not really. Flask is also great for this. We have simple test cases, small tests, that take like 20 seconds to 30, that run some basic requests. And if you mess up the schema, these fail. These fail almost always. And by running this, you just know if you broke it. We also have a tool in development that's open source, which we call schemathesis, which is like schema and hypothesis. So it will take your schema and create test cases automatically to test those crazy things like a million, number that's a million, or negative numbers, and things that you don't think about too much actively, but they hide as bugs. But this is still in development, so I didn't add it to the presentation yet.
First of all, thank you for your awesome speech. I have a question, maybe it some kind relates to deprecation. Is it possible to extend the schema? For example, if I implement new version of API and the only difference is a one new field, do I need to copy and paste schema, for example, like it was version 1, then it's version 2, do I need to copy to make an exact copy with only one new field?
No. OpenAPI allows a specific subset of JSON schema And JSON schema allows you to have composite fields. So you would have everything from one, and you add a new value. So you could have entire bird, and you just add eggs, or number of eggs, or egg type.
Okay, I get it. And so it applies. Does it apply to another situations, like when we have the same base bird, and one service extends this schema with one field, another service with another field?
Yes.
So it
can
will work.
Composite it as you want.
Okay, thank you.
I personally wouldn't recommend it. It's better to have like an authentic version that everybody shares. But if your use case needs it, it's possible.
Okay, thank you.
Is there a convenient way to separate schema definition from default from example values? I mean, I don't want to keep these example values for Swagger requests example. In main schema definition, I won't have different files.
From what I've noticed, depends. In this case, I would recommend just to keep it there, because it's easier for people who are not developers to read it. Let's go to the base. Like if you say that it's a unique name associated with the bird, it takes a little bit of reading comprehension. If you provide an example or put it as a pigeon, it's much more obvious for people reading it. Generally, you can have composite examples so that you don't have to put field by field examples. You can have one example for the whole composite, for the whole object. That's possible. Could be the closest to what you are imagining.
But is it possible to separate, to have two files, one with schema definition only, and another one with some examples?
I didn't try it, so I don't know, honestly.
Okay.
Any other questions?
Yes.
What are the reasons to use OpenAPI compared to GraphQL?
That's a long discussion that we've had many weeks, arguments about.
So you have probably some summary?
Summary is that GraphQL is very useful if you can start with GraphQL. Yes. If you have an existing API, putting GraphQL there is nearly impossible in a logical value.
For starting, you recommend to use GraphQL?
I don't recommend it per se, because it's not that widely adopted. Like if you started something you wanted to interact with, you will need some kind of REST-ish API or HTTP, properly API, eventually. So it depends. If you're doing an internal service that you want to have lightweight, GraphQL is great. But if you want to have a big production-ready API that you want to share with your partners, GraphQL is still too young, especially considering things like caching and database optimizations. Well, we tried even some production applications of GraphQL in our internal teams, but somehow it would almost always end up with GraphQL DDoSing us from inside. It depends. If it was from the start on, I think we could have avoided this, but usually if you have a running application, you have some database level logic and some backend logic, and GraphQL doesn't play too well with this.